Good morning. My name is Jen Weber, and I work at a startup called BioBright, where I use Ember to build applications that advance scientific research. Today, I'm here to share with you some of the things that I've learned while building custom visualizations for scientists. Now, before I was a developer, I had a background in biology. So when I took this job, I thought to myself, I'm going to need to build so many graphs. Scientists love graphs. So I did what I always do, and I read a book. It was an introduction to a popular charting library, so that on my first day of work, I was so prepared to build graphs. Bar charts, line graphs, scatter plots, you name it, I was ready. But then my first visualization task came in. And it was kind of overwhelming. I needed to build a technical diagram that was interactive, that would help scientists view the historical data. I needed to be able to switch between 3 different units of measure, and I needed to have a dial that would update in real time with an object's rotational position in space. These things were not in my book. But I knew that I needed to give scientists something better than just some numbers flickering on a page. So I thought to myself, what do I know? I knew from my book that a lot of popular charting libraries, like D3, like HighCharts, they're essentially helpful wrappers for SVGs. SVG stands for Scalable Vector Graphics. They're drawn dynamically by the browser, so no matter what size the image is, it's always clean and crisp, unlike JPEGs, which are pixel-based. I also knew that SVGs were kind of sort of images made out of code, technically XML. The size, position, and appearance of different shapes on the page were all controlled by attributes and styling that looks a lot like CSS. I also knew that SVGs were easy to find and make. A lot of image editing programs are vector-based. So who here uses Adobe Illustrator? All right, handful of people. Has anyone used Inkscape? Great. So if you haven't heard of it before, Inkscape is a free open source alternative to Illustrator. My experience prior was in Illustrator, and I found that I could export my Illustrator files as SVGs, and then copy and paste the XML into my projects. There are also plenty of Creative Commons sources of SVG assets too, if you don't want to make your own buttons, dials, and diagrams. And I knew a thing or two about Ember. I knew that I had an ambitious app to build, and I really wanted to see how far could I take this statement that Ember was more productive out of the box. So I decided to see how far I could get without any add-ons, without any node modules like these charting and animation libraries. Just Ember. Today, we're going to walk through a couple different examples of some things you can build, even if you're new to SVGs or even Ember. I've made a few minimal demos that you can play around with so you can see for yourself how the code works, and I'll share a link to those at the end of today's presentation. My goal today is to give you enough information to be dangerous so that you'll be ready to tackle use cases like the one I described at the beginning. The examples will be super simple, but hopefully you'll be able to see how you can extend from them. So let's start with the basics of SVGs. If you open up an SVG and an image editor, you'll see a picture. But if you open up that same file in your text editor, what you'll see is an XML document kind of like this. It has DOM elements and styling. SVG elements can be styled with CSS, whether embedded styling, like in this example, inline, or external. But you should know that a few things work a little bit differently. For example, some style attributes that you know off the top of your head aren't going to work for SVGs. Background color becomes fill. Outlines become stroke. So you can even use CSS animations on your SVG. If you were here yesterday, you heard Jessica speak about a few different approaches to animations, and a lot of them will work in this environment as well. This animation in particular uses keyframes, which is part of CSS3. And I specifically wanted to share with you this example by Sarah Swadan, because Sarah's articles were what really helped me get started with building my own visualizations, even after just reading 2 or 3 of them. So I really encourage you to take a look at her work. Finally, you need to understand what it means to say that SVGs follow paint order. There is no such thing as z-index when you're working with plain SVGs. So whatever is lowest in the DOM is what forms the top layer that's visible to the user. So if this painting was an SVG, the groups of trees and shrubs in the foreground would be lowest in the DOM and therefore the top layer visible. You might also notice here that I'm using this tag G. G stands for groups. Groups are a convenient wrapper for organizing objects and shapes within your SVGs and applying classes without changing anything about the layout of your images. All right, so with the basics out of the way, let's talk about how to emberify these SVGs. Now, to be totally honest, there are some unusual pitfalls in SVGs in Ember. But I want you to know that when I built my first app using SVGs, it was in Ember. I was 1 month into my first job, and I had learned how to code 4 months prior. I tell you this so that you'll believe me when I say that SVGs are fun to build and they're straightforward to debug. So let's start with adding some actions. So in this case, we have a technical diagram that a user can interact with, a Raspberry Pi. A click reveals the label for each piece. Now, each part of the Raspberry Pi, each individual component, is actually composed of many different shapes within that SVG. So in order to trigger our actions when a user clicks on any part of it, we place the action tag within the group. This is really a lot like adding actions to divs, right? So in this example, when a user clicks on something, it sets the heading to be the name of that part. In my app for scientists, what I actually did was a hover would show the label, and then a click would take the user to a page where they could view historic information about that part. And since I used Ember to handle the actions, I was able to manage my application state in the exact same way that I would have if these were buttons or links. So historical data is useful, but a lot of scientists are interested in getting real-time information from their devices and sensors, like temperature, for example. And there are many different progress meter or thermometer type add-ons and packages available. But let's say that you have something that has really specific requirements. Maybe it needs to look different based on different conditions of the lab. So here we can write a computed property, temp status, that would apply different styling based on different conditions. And we can control the thermometer's level by using the height property on a rectangle that forms the height of the thermometer. But in SVGs, here's what changing the height does. So that's not really what I wanted, that's for sure. This brings me to the first pitfall of working with SVGs. The top left corner is 0, 0. That's the origin. As a scientist, I found this to be super strange, and it took a long time for me to get used to. The shapes within an SVG are positioned using their X and Y coordinates within the SVG view box. You can kind of think of the view box as the frame that's visible to the user. So in this default case, if something had negative X, Y coordinates, you wouldn't be able to see that shape. So all of this takes some getting used to. I think of it kind of like when you learned CSS for the first time. So when 0, 0 is in the top left corner, it really affects what your animation looks like. So here's the default behavior of a rotation. And this is the default behavior of changing the height. But we can do something about this. To fix this problem, I used a transform. With a rotation transform, you can set the X and Y coordinates of the axis that you want to rotate on. So I set my axis as the top center of the rectangle that formed the thermometer height, and then I rotated it by 180 degrees. Now here's what our thermometer looks like. So again, this is a little bit weird, right? But I can see with my own eyes when something's not going right, and I have lots of Stack Overflows and CodePens and demos and blog posts to guide me towards fixing these kinds of strange things. So I was feeling pretty confident after solving this thermometer challenge, so I decided to drive off the edge of the map. Could I use Ember data to generate shapes on the fly, and I could use the each helper and components in my templates to display those shapes in a very Ember-ish way. And although it seems like the obvious next step, Googling really didn't yield many results for me about using Ember data in this way. And we're about to find out why shortly. When I sent some data down to a component using an each helper, this is what rendered in my graph. No data points, no error messages, nothing. This is why I think there aren't many articles about using components with SVGs. People see this and they think, oh, it must not work in Ember. But I wanted to be sure, so I opened up the inspector and I started digging around. Which brings me to pitfall number 2. Unsurprisingly, if you put a div inside of an SVG, it breaks things. By default, Ember components are wrapped inside of divs that Ember itself generates. But luckily, we have this nice wrapper that we can use that won't affect our layout. So if you pass the G as tagName, whether in your components JavaScript or the template, then Ember will wrap the component in a group instead. Once I made this change, my data points rendered. And this was awesome because now a user could click on data points to add their notes and commentary. I could use Ember data to persist changes and save state. So next, I wanted to add some labels so that when a user hovered over a data point, they would know right away what they are interacting with. That brings me to pitfall number 3. So when I was building this application, I just sort of naturally grouped each of my data points with its label in the same component. But I found that my labels were obscured by other data points. So in this example, the circle and its label are rendered together, so the next data point is lower in the DOM, and therefore, that's the top layer visible. So to get a better idea of this problem, let's watch the current render order stepping through the DOM. So fundamentally, unless I have sorted my data points, I can't make any guarantees about what order they're going to show up on the screen. The solution here is to be thoughtful about paint order and how it affects your app. So what I did was I wrote a sort definition based on the y coordinates of those data points so that the data with the lowest y coordinate gets rendered first. And here's how that turns out. So now, the points and labels of lower rows will always be lower in the DOM, and we've eliminated that overlap. And our final pitfall. If you're on an Ember version less than 1.8, you're missing out on some SVG functionality and a whole lot of other things. The solution is to, unfortunately, upgrade your app. So that's the last of the pitfalls. Next, I'd like to show you what it looks like when we put all of these things together. So, one awesome thing about building apps for science is that if you're doing it right, you'll have some measurable outcomes. At the beginning, I told you a little bit about my first visualization project and how I was determined to create something different than just numbers flashing on a screen. I really wanted to help scientists improve their workflow and make their data more accessible and more clear. And I'm happy to say that we had some pretty great outcomes. So for these scientists, we gave them an interactive diagram to help them count out rows and columns on an itty-bitty device. This example is greatly simplified, but it will show you most of the basic components. So by using if helpers, bound classes, and computed properties, I can actually overlay and color code data right here on the diagram. I can manipulate the data based on a click or by voice command, since I was also building an app that needed to be hands-free. I used the scatter plot approach that we covered earlier to generate each of these little circles, since the arrangement of those circles varied from experiment to experiment. I also made a dial to display the rotational data that we had coming in from one of our sensors. The turns that the scientists needed to make as part of their experiment had to be precise. So in later iterations, I even added a target to the dial so that they could see when they were close to their goals. So how did I actually set this up behind the scenes? This is the model that forms one of those circles or data points. And for simplicity and human readability, each of my circles had a simple XY coordinate that was a whole number that corresponded simply to its row and column in this array. Then I used a computed property on the model, or you could do this in a component, to actually position the circle on the body of the SVG. So in cases where I needed to position something relative to that circle, like its label, This was really easy to do with Ember data and computed properties. All I had to do was add or subtract from the circle's XY coordinates in order to place my label. So on a hover over the circle, I'd set this property show label to true, and then position the label using the XY that we set up in the component or the model. All right, so what about this rotation dial? What about the real-time data? One of my coworkers created a computer vision system that tracked an object's rotational position, and it was my job to display that sensor data in real time. I decided to do that using a rotation transform. So the data came into this object current orientation at a rate of 3 or more messages per second. I was a little bit worried about what that fast-moving data would do to my SVGs, but what I found was that I didn't need to downsample. By using data and SVGs, it just worked. Since we were asking users to report their estimations of these turns that they were making, and we could give them a visual output, this system made it easy for us to compare the differences between the changes a scientist meant to make and the changes that we were measuring on our sensors. So we ran the numbers. This is what 20 times improvement in scientific accuracy and precision looks like. With the right tools, scientists make fewer mistakes and achieve more reliable results. When I started this project, all I had were some wireframes and mock-ups that in some ways I was almost afraid to create because I had no idea how I was going to actually build them within the ecosystem of our existing Ember app. But outcomes like this are why learning how to build custom SVGs is worth the effort. So I'd like to leave you with some considerations and learning resources. The material and techniques that we've covered here today, I would say these fall under learning and exploration mode. If you want to put these practices into production, you'll need to do a little bit more research to make sure that your app will work for people who aren't just like you with a high-powered computer and the latest version of Chrome. First up is accessibility. It takes a little bit of work to make sure that screen readers can still navigate your SVG interface, but it can be done, and there are some great tips if you just follow this link. Next up is cross-browser compatibility. And my recommendation here is to test your app incrementally as you're building it. You don't want to have any surprises on deployment day, and there are some attributes of SVGs that simply aren't done in a lot of browsers yet. Lastly, SVGs exported from popular software usually need some cleanup and optimization in order to work well in your app. They're not going to look as neat and clean as some of the examples that I showed you earlier. But luckily, there are some tools available to help you optimize your SVG just by copying and pasting it in. And there's also some settings in each of those programs that will help to simplify the points and the paths that make up the shapes in your SVGs. It's also a good idea to do a little bit of benchmarking because there is a limit to how many DOM elements you should try to programmatically render, animate, and bind things to. So the good news is that now that you know a few things about SVGs, a few things about how to use them in Ember, you have an incredible wealth of knowledge available in the form of non-Ember tutorials and articles. As I mentioned before, my favorite author on this topic is Sarah Swadan. Also, once you have the basics down, it becomes so much easier to understand and start using more advanced charting libraries. These libraries are awesome. They exist for a reason. If you play around with SVGs in Ember, using the techniques that you're familiar with, these libraries will seem much friendlier. And depending on your use case, they will save you a lot of time and frustration. So some people have asked, how would I know when I should try to make my own images as opposed to using one of these libraries? And what I would say is, if you can copy and paste somebody else's example and make some small changes using one of these libraries, do that thing. You don't need to do everything by hand. But now that you know how, you can be more prepared for that moment that you have to build something unusual. So I'd also like to ask, who here has used some of the techniques like I described today? Awesome. So what I would ask you to do, if you're able, is to write about it and share it with others. So, as Bill Nye would say, consider the following. With every month that goes by, the line between design and development gets blurrier. Our websites are starting to look and flow more like phone apps, things that you can touch, things that you can talk to. And more people with creative skills, like vector illustration, are joining the development community. They're reliant on the quality of our teaching and the ease of use of our tools. Meanwhile, we as developers are pushing the limits of our own creativity every day. And what this means is that together, we have an opportunity to build some really awesome things. If you'd like to see demos of these animations, please follow this link here that'll take you to an Ember Twiddle. And if you've never used Ember Twiddle before, it's kind of like JSBin or CodePen, but it's for Ember, and it's one of my favorite ways to explore new techniques and tools. If you have any questions or you have some ideas about how you want to use SVGs in Ember, we can chat later today, or you can always find me on the Ember community Slack. My name is Jen Weber, and thanks for listening.